Hey, Anna, we did not finish notes from yesterday for 2.7, so we're going to finish that today. I'm going to recap just a little bit before we do our last example, example 3, about precision versus accuracy. Okay, do you remember what I called which one? What does precision mean?
Correct. No, precision is continuous.
Precision means consistent. Consistent. Accurate means good or correct, right? Good. Okay. Now, how do you get more precision?
Be more accurate.
Most of the time they go hand in hand, but more precise. You get more precise if you have.
It's like all in the same spot.
High focus.
Like if we're talking about yes, like if you practice or whatever, but smaller increments, right? You are more precise if you are measuring to smaller increments, right? Okay, so we're going to elaborate on that today, but like if I measure to the nearest inch rather than to the nearest foot, or if I measure to the nearest point, like we had this little line segment right here. If I go to the nearest millimeter or 0.1 centimeter rather than to the nearest centimeter, it will be more precise of a measurement, okay? Now, how do you get more accurate?
Practice.
Well, practice is both ways, right? Accuracy means good. Accuracy means how close you are to the actual.
Just being good in general.
I'm gonna say reduce the, what do they call it? Error? What kind of error? Approximate error. You reduce the approximate error.
Stop. You can't scare me like that.
Okay? That's how you get to be more accurate or more good, is you reduce your approximate error, like how far you are away from the actual, right? Okay? So like on this example 2, where we had something that was 10 grams and the spring scale measured it to be 9.86, the lab scale measured it to be 9.92, the food scale measured it to be 10.3. We said that this one was the most accurate because it had the least amount of approximate error, like the least amount off from what the actual should be, right? Kaylee's looking at that like, what the heck does that even mean?
I'm still trying to figure it out. Wait, were you curious?
Yeah.
I was serious.
Yeah. Okay. Approximate error. Approximate error. All right, here we go. Example 3 is kind of a loaded example, so buckle up. Here we go. We'll do example 3, and then I'll help you with number 6 on your homework assignment. I'll get you started on number 6, okay? So number 3, we have a carpet square here that this person has measured to be 10 by 8 foot, 8 by 10, right? Okay, and it says the carpet he chooses is $2.63 per square foot, all right? So I'm going to go over here, and I'm going to say, let's say it was exactly 8 by 10. Let's say he was exactly 8 by 10 foot, because that's what he said it was, right? If he was 8 by 10, that is how many square feet? 80 foot squared, right? Like if I multiply those together, 80 square foot, okay? If it is $2.63 per square foot, how do I calculate the cost? Times 263 times 80. And how much would it cost if it was exactly 8 by 10? 210.4.
Okay, that's not
$210.40. Okay? If it was exactly 8 by 10, right? Okay? But we're going to talk about like the error that could have possibly occurred, all right? So when I look at the numbers 10 and 8, what did they round to? The nearest what? No. They rounded to the nearest whole foot, right? Okay? So like this number, this 10 foot wasn't 9 feet and it wasn't 11 feet, but it could have been anything bigger than 9.5 feet, because that would have rounded to 10, right? And it could have been anything smaller than 10.5 feet, right? Both of those measurements would round to 10 feet, true? Right? Because he rounded to the nearest foot, right? Okay, over here, 8 foot wasn't 7 foot, and it wasn't 9 foot, but it could have been anything bigger than 7.5, and it could have been anything smaller than 8.5, because those numbers would round to 8, right? So at the very, very, very smallest, I'm going to talk about the smallest this could have been. At the very smallest, this could have been not an 8 by 10, but a 7.5 by 9.5, right? Because those measurements would still round to be 8 by 10, true? Does this make sense? At the very smallest. At the very largest, this rectangle could have been 8.5 to 10.5, right? It could have been an 8.5 by a 10.5, right? Does that make sense? 8.5 right here
Where are you getting 10.5?
and 10.5 right here. Okay? So at the small end, he's a 9.5 by a 7.5, right? At the large end, he's a 10.5 by an 8.5, right? Does that make sense? Those are the largest amounts that those could be, right? This is for height, and this is for width, and this is for height, and this is for width, right? If he measured the height to be 8 exactly, it could be anywhere between 7.5 and 8.5. If he measured the width to be 10, it could have been anywhere between 9.5 and 10.5. Does that make sense? Okay?
What if he's a 7.5 by 10.5?
Then that increment would fall in between the smallest and the largest. Okay, so let me keep going real quick, right? If I take 7.5 by 9.5, what square footage is that? What's 7.5 times 9.5? 71.25. Okay, and what's 8.5 by 10.5? How many square footage is that? 98.2. 88.25.
89. Sorry.
You're fine. 89.25. Okay, so there is that. That's how that works, right? Okay, now Otto just asked the question, what if it was 7.5 by 10.5? That's going to live somewhere between 71 and 89, right? Okay, because at the very smallest, these are the smallest dimensions, right? These are the largest dimensions it could be. So if it's small on one end and big on the other end, then it's still going to live somewhere between these two. Does that make sense? What is 7.5 by 10.5? 78.75. Do you see how that lives in between there? In between those two? Okay. So on the very, very small end, I'm going off of my smallest increments he could have been, right? 7.5 by 9.5. On the very largest end, I'm going off of my largest increments, right? Okay. But now, let's multiply those by 2.63, which is the amount per square footage, right? Okay. So what's 71.25 times 2.63? 187.39. Okay. What is 89.25 times 2.63? 0.73. Okay, so here's the deal. If this carpet square is exactly 8 foot by 10 foot, I'm going to pay $210.40. But it may not be exactly 8 by 10. I know on the low end it's going to be 7.5 by 9.5, in which case I'm going to pay closer to $187. On the large end, this could be an 8.5 by a 10.5, in which case I'm going to pay closer to $234.73, right? Now, that's still a pretty wide gap. I'm going to pay somewhere between this much and this much. This is the max that I'll pay, and this is the min that I'll pay. And that's still a pretty wide gap. Like, that's a $50 gap. True? Yeah? Like, that's a pretty decent sized gap. So, how do I make that gap smaller? Smaller increments. Let's, instead of doing 10 feet, let's go to the nearest inch or the nearest half of a foot, right? Okay, let me go to part B right here. Part B says that he checks the dimensions of the room again and measures it to be 9.8 and 8.2. Okay, so now I'm going to change my dimensions again. Okay, was the 9 point, yep. The 9.8 was here, feet, and the 8.2 was here, feet, right? Okay, so now, instead of it being a 10 by 8, now it's 9.8 by 8.2, okay? Now, how much am I off by here? Like, what's the largest it could be or the smallest it could be? 9 and 10. No. 9.8, the next increment below would have been 9.7, but it wasn't 9.7. So that means the smallest it could be was 9.75, right? Okay? It wasn't 9.9, right? So that means it has to be smaller than 9.85, right? Okay? Now, what are my constraints for the 8.2? It wasn't 8.1, so that means it has to be larger than 8.15, okay? It wasn't 8.3. That means it has to be smaller than 8.25, right? You see where I'm getting these numbers from? It's like the half distance between the next increment, right? So on the low end, my dimensions are going to be what? By what? 8.15 by 9.75, right? On the high end, it's going to be 8.25, girls, by 9.85, right? If I round to the nearest 0.1 feet, those are my dimensions. All right, let's figure out what this is. What's 8.15 times 9.75? And then somebody else do 8.25 by 9.85.
The first one's 79.5 if we're rounding.
Okay, and that's square feet. Okay. The bottom one is 81.26 square feet. Okay, now I'm going to take those numbers times, the dollar amount, which is 2.63, right? 2.63.
Why do we take it
Because it says it's $2.63 a square foot. For the cost of the carpet is $2.63 per square foot. Okay? All right, so on the low end, I'm going to pay how much, and on the high end, I'm going to pay how much?
The low end, 209.09.
209.09.
And the high end would be 213.7.
0.70, right? Okay, so just by rounding to the nearest like 0.1 feet, right? By rounding to a smaller increment, now look at the gap between what I will pay.
It's a lot.
Now it's a lot closer estimate, right? Okay, because the amount that I could be off by is a lot smaller if I measure to a closer decimal place. I'm more precise in my measurement, right? Okay, does that make sense? Like the gap, the window of error gets smaller, the further decimal place you go. Confusion? Okay, let's look at number 7, or not 7, number 6 on your homework assignment. The homework assignment is 2 through 16 evens, by the way, if you want to write that down. 2 through 16, the evens. 2 through 16, the evens. Blue Hill Schools. Yep. Okay, so number 6, the Public Works Department is paving some of the roads, and the material needed to pave is $2.50 per square foot. Okay, they have this road measured to 45 by 100 feet. What do you think they rounded to? The nearest. I would say they rounded not even to the nearest foot. I would say they rounded to the nearest 5 feet, right? Because both of those are increments of 5, true? Right? Okay. So this could have been 40 feet and this could have been 50 feet, right? But it's not. It measured to 45 feet. So what's the lowest that this could have been? To still round up to 45. Just go. Yes. What?
45. Wait, are you wanting the lowest?
The lowest it could have been. Like to round down to 40 and to round up to 45.
41.
You're close.
42.
42.5. If it's lower than 42.5, they're going to say it's 40, right? If it's higher than 42.5, it's going to round up to 45, right? Okay? This guy, what's the cutoff mark for that? 47.5. It's higher than 47.5, they're going to say it's 50. If it's lower than 47.5, they're going to say it's 45. Does that make sense? Okay. This guy, my 2 increments over here could have been 95 and 105, but it wasn't. They rounded it to 100, right? So what are my 2 cutoff marks? That's the lowest it could have been and the highest it could have been. 97.5, right? Anything lower than 97 is going to round to 95. Anything higher than 97.5 is going to round to 100. Right? What's the cutoff mark here? 102.5. 102.5. Okay? So if we're talking square footage, on the low end, let me do it over here. On the low end, my pavement is a what by what?
42.5
42.5 by a 97.5. That's on the low end for square footage, right? It's a 42.5 by a 97.5, okay? And then on the high end, it's a 47.5 by a 102.5, okay? Now, there could be other dimensions in there, but those are on the low end and the high end, so everything else is going to live in the middle, right? So I'm going to say X. I'm going to say A, actually. The area is going to be bigger than this one, but less than that one. Does that make sense? Okay, let's actually figure out what those are. So my area is going to be in between these two numbers. What's 42.5 times 97.5 and the other way? The other one. 4,000?
4,143.75.
And that is in feet squared.
And then the other one is 4,868.75.
Okay, there's that. So I know that my square footage for this road has to be somewhere between those two. Now, that's still 700 square feet off in between those two. And what did I round to? The nearest how many feet? 5 feet. I rounded to the nearest 5 feet, right? Okay. So if I wanted to make this increment smaller, like the square footage difference between them smaller, what could I have done? The nearest foot even, right? We went to the nearest 5 feet. We could have done the nearest foot instead, right? Okay, do you see how that works? So on the low end, this is how much square footage I have. On the high end, this is how much square footage I have, right? Okay? Now, what's the possible range for the cost of the materials? How do I figure that out?
Multiplied by 250.
Yeah, each one of those constraints multiplied by 250, right? 250 is my square footage. So if it's this square footage, that's the low end. Take that times 250. What'd you get? That's still going to be a lot of money. Still going to be like close to $10,000.
Are you wanting this first?
I'm going to guess bigger than that.
Are you wanting the low one first or the high one?
It doesn't matter. Whatever you want.
Okay, the low one is 10,359.36. No, 38.
38?
38.
$38.
And the high one is 12,171.88.
Okay, that's a difference about $2,000. If I came to you and I said, we're going to do 100 foot of road and it might cost you 10,000, it might cost you 12,000, you'd be like, I really need to know which one it is, right? So how do I be more precise on my measurements? How do I get you a narrower gap, like a better gap between those two? Go to the nearest foot instead of the nearest 5 feet, or go to the nearest inch instead of the nearest foot, right? I do smaller increments and that will make this gap smaller, right? We just kind of guessed that that's what they did, right? Because those numbers were both divisible by 5. They could have gone to the nearest foot, and it just so happened that it turned out to be 45 and 100. But the fact that those are both divisible by 5 makes me think that they probably went to the nearest 5 feet when they're measuring. That's what I'm guesstimating. Yeah. Okay. Good. Makes sense? Ish, kind of. Okay. So that's it. 2 through 16 evens on the rest of it.
And so,
Okay. All right. Goodbye, Anna.